Into way a Bellman-Ford algorithm. In the Bellman-Ford algorithm, the advantage is that you can work with negative numbers. Okay, I solved it here, but it was becoming messy or dirty, so I decided to make it clean. That's why. So, in the Bellman-Ford algorithm, what you have to do is you count the number of vertices: 1, 2, 3, 4, 5, 6. And Bellman-Ford say that if you have 6, it is 6 minus 1 iteration. That means you do 5 iteration. If you have 7, 7 minus 1 iteration, 6 iteration. If you have 8, 8 minus 1 iteration, 7 iteration. So it is the number of vertices minus 1 iteration. So we will go over that number of times. Okay. This is what Bellman-Ford is saying. Bellman-Ford is saying that we have to have our source where we will start from. In this case, we are starting from source A. So we are starting from source A. See, the source vertex plus the edge will give us the value here. And always note, if the value here is less than the addition that is coming, then maintain it. But if it is greater than, update the table. Assuming 0 plus 6 will give you 6. But if there was already a value here like 9 or 10, that means that remove that one and write 6. But if the value here was 3, that means that maintain the 3, don't update the table. That is what Bellman-Ford is saying. So by so doing, you will go over and over again until the numbers don't update again. Okay. Now, so I wrote down the vertices AB, ED, EC, EB, ED, EC. So here are the vertices. You can arrange it however you like. Okay. So by so doing, now let's start. We are going from the initial state. Every place is infinity. B is infinity, E is infinity, C is infinity. All of them, with the exception of A, which is our source, it is always 0 because we don't know the cost involved or the amount it will take us to travel from A to B for the initial stage. From B to E, we don't know all the costs involved. I hope you understand. Good. So at the initial stage, we initialize everything to infinity. Only the source, it is 0. Okay. So we are now going to calculate the source plus the cost here or the edge here. Then we update the table. So AB 0, 6. 0 plus 6 will give us what? It will give us 6. Here is already infinity. 6 is less than infinity, so we write 6. I hope you've gotten it. Okay, let's go to AD. We check AD. Have you seen it? Okay, what is the cost involved? I think D has a value. I did not write, sorry. AD. A is 0. 0 plus 5. That would be 5. You write it here because D is infinity and 5 is less than infinity. Okay. AC, A to C, A is 0. 0 plus 4. That will give you 4. C is infinity, so you update it. 4. When you are done, you underline it for you not to mess up and do it again. B, E. B, E. B is currently 6 minus 1. That will give you 5. Have you seen it? Because E is infinity. Okay. CB. CB. C is currently 4. 4 minus 2. 4 minus 2 will give us 2. So you update B. DC. DC. D is currently 5. 5 minus 2. That will give us 3. 3 is less than 4. You update it. DF. DF. D is currently 5. 5 minus 1. This will give us 4. CE. CE. C is currently 3. 3 plus 3. That gives us 6. But 5 is less than 6. So let's maintain it. EF. 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 I think here was 3. E is currently 5. 5 plus 3. That gives us 8. So we maintain this. So we are done with the first iteration. We have gone over the first time. So we go over the second time again. Okay. Okay. A, B. A is 0 to B. 0 plus 6 is 6. But here is 2. So we maintain it. AD. A is 0. 0 plus 5. It will be 5. Here is 5. So we maintain it. AC. AC. A is 0 plus 4. It will be 4. But here is 3. So we maintain the 3. BE. BE. B is 2. 2 minus 1. That will give us 1. But here is 5. So you update it. 1. CB. CB. C is currently 3. 3 minus 2. And that will give us 1. Here is 2, so you update it. 1. DC. DC. D is currently 5. 5 minus 2. That will give us 3. 3 is there, so you will leave it. DF. DF. 5 minus 1. That will give us 4. We leave it. CE. CE. C is currently 3. 3 plus 3. That is 6. Here is 1. You leave it. Okay. EF. EF. E is currently 1. 1 plus 3. That is 4. You leave it. Now, you update the table again. We are done with our second iteration. We're going to our third iteration. So we update the table again. AB. A to B. 0 plus 6, 1, we leave it. AD. 0 plus 5, 5, we leave it. AC. A to C. 0 plus 4. Here is 3, so you leave it. BE. B to E. B is 1. 1 minus 1. Here is 1, so you update it. It becomes 0. CB. C to B. 3. 3 minus 2. That is 1. So you leave it. DC. DC. D is 5. 5 minus 2, 3. So you leave it. DF. DF. D is 5. 5 minus 1. Here is 4. So you leave it. CE. CE. C is 3. 3 plus 3. Here will be 6. But 0 is less. You maintain it. EF. EF. E is 0. 0 plus 3. That will give you 3. But here is 4. So you update here. 0 plus 3. 3. You update the table. So you are done with the third iteration. You go over the fourth iteration. Let's go over the fourth iteration. A, B, 0, 6. This is far good. AD. AD. 0, 5, 5. AC. AC. 0 plus 4. But here is 3. So here is good. BE. 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 1 minus 1 already 0. CB. CB. 3 minus 2, that is 1. Good. DC. DC. D is 5. 5 minus 2, that will give us 3. So DC is okay. DF. DF. 5 minus 1. That is 4. Here is 3. So here is good. CE. 3 plus 3. That is 6. Here is 0. Here is good. EF. 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 0 plus 3. That is 3. So we did not do any correction. So that means on the third iteration, we had A to be 0. On the third iteration, we had A to be 0, B equals 1, C equals 3, D equals 5, E equals 0, F equals 3. So this is the shortest path for this Bellman-Ford algorithm. Thank you.